This cool thing called substitution. Hopefully you got some practice with it yesterday. I want to be able to determine this antiderivative. Looks super complicated. If you were going to take the derivative of this, it would require the chain rule, wouldn't it? What would the inside be? Yeah, so I got u is equal to x squared plus x minus 1. So therefore, what is du? 2x plus 1 dx. Shoot, I don't have a 2x plus 1. I got a 4x plus 2. Multiply by 2. 2 du is equal to 4x plus 2 dx. How do you like that? Not too bad, huh? All right, so the new integral is 2 integral du. When I say 2 integral du, what does that get rid of? 4x plus 2 in the dx. What's left? U to the negative third, right? Antiderivative of u to the negative third. Over? Negative 2. Over negative 2. I multiply. Those 2's cancel. Hello, Hannah. The 2's cancel. I get a negative result. Negative 1 over u squared, or x squared plus x minus 1 squared plus that constant. That's that antiderivative. Hannah, what are we doing? What are we doing? We're doing tests. Awesome. Sweet. You tell me when you're ready, and I'll be there. You ready? Take out your sheet of notes that you get, that decision tree. Uh-oh. What's that? So when I take the antiderivative, I increase the exponent by 1 and divide by the new exponent. All good? Okay. I want you, as I help my dear friend, I would like you to decide in this problem what you think u is. Because there's a big debate about it. Talk to your partner, see what you can come up with. There is a right or wrong answer. Ready, go. Okay, I gotta hear what people got. Is u equal to e to the x, or is u equal to e to the x plus 1? Here is the most important element of understanding what you choose for substitution. So far, because I don't have a really good answer, I've said, hey, what do you choose for substitution? Well, if you're going to do the chain rule, what would be on the inside? Well, when you're looking at this, you're like, well, chain rule, you don't have to do it. Use the quotient rule, right? If you're going to take the derivative. So you're like, it doesn't really make sense. Here's what you choose u to be. When you take the derivative of u, you want to come up with what's left over. So if I take the derivative of e to the x, do I come up with e to the x plus 1? No. But if I take the derivative of e to the x plus 1, do I come up with e to the x? Yes. And that's why this is incorrect and this is correct. Does that make sense? We'll get there. So therefore, du is equal to what? E to the x dx. Do I have an e to the x dx? I sure do. It's right there. So I get to cancel those off. Integral of what? U to the negative 1, or 1 over u du. Oh, no. Wait a minute here. If let's see, you guys wrote that as u to the negative 1. So if I took the antiderivative, I would do u to the 0. Oh, no. Oh, no. Somebody out there. Is there somebody who knows what do we take the derivative of to get 1 over x? Natural log. Yeah, folks. Do you remember this? If you had the natural log of x and you took the derivative of natural log of x was 1 over x. So the antiderivative of 1 over u is the natural log of u. There you go. So you have the natural log of e to the x plus 1 plus that constant. Sweet. Was that awesome? All right, talk with your friend. What's u for number 8? Go. So we choose u in this situation to be sine of x. So therefore du is equal to cosine of x dx. Excellent. So therefore, if I write the integral du, what do I cross off? I cross off cosine of x dx, correct? What's left over? 4u squared. Shania brought up a good point. She's like, well, wouldn't we have to multiply both by 4? You could, or you could just write it like that. Either way, it's no big deal. We can take care of it. What's the answer of 4u squared? Over 3, yeah. So 4 sine cubed over 3 plus constant. Awesome. You've got the easy substitution problems down. Let's try the more difficult ones. We have a difficult situation here. What do you choose u to be? X squared plus 2. Now here's why this is a bad deal for us. Because du is equal to what? 2x dx. Now we know how to get rid of the 2, don't we? What do? Yep, so 1/2 du is equal to x dx. So why do I have a problem? Yeah, I got x cubed here. I'm missing like x squared. You guys see how easy it is to just change something in an integral and all of a sudden becomes ridiculously challenging, doesn't it? That's the challenge with integrals. So it makes it so much more complicated. I'm going to change something, see if you can figure this out here. We're going to write this as integral of x times x squared times x squared plus 2 to the 5th dx. See how I just separated that? So I have an x dx now, and then I got this x squared there. So I'm going to write my integral 1/2 integral du. If I write my integral 1/2 du, what do I get rid of? X dx. Now, we all know, Asher has pointed out, so have others, that we got this extra x squared thing floating around, right? Don't worry about that yet. What can I replace this with right here? U to the 5th, okay? So that's u to the 5th right there. And now I've got to get rid of that x squared. Nice thought. Unfortunately, that doesn't work. I need to write everything so as a variable of u. I wish that there was some equation up here that related u and x squared together. U minus 2 is x squared, isn't it? Whoa. So therefore, instead of x squared, I put in that place u minus 2. So this integral, I have 1/2 integral of u to the 6th minus 2u to the 5th du. Now it's a piece of cake, isn't it? Upside down. 1/2 times antiderivative u to the 6th. minus antiderivative 2u to the 5th. Yep, use 6 over 3. Plus a constant. I got to multiply through by that 1/2, don't I? And what do I put in the place of u? 1/2 times, or I'm sorry, we said we are going to get rid of that. My apologies. X squared plus 2 to the 7th over 14 minus x squared plus 2 to the 6th over 6 plus a constant. Wow. It turns out that if you take the derivative of that, you come up with that. That's hard to see, isn't it? I mean, if you just flip back, I mean, I don't think that this was that bad. The derivative of 4 sine cubed of x over 3 ends up being 4 sine squared times cosine. Like, I can kind of see how that works out. But this guy right there, the fact that if you take the derivative of this, you come up with that, that's a lot more difficult to see. Good job. You're going to handle the next one just fine. If you saw that, you're going to be good to go the rest of the way here. We got 3 more. What do you want u to be? Good. So then du is 3x squared dx. Divide by 3, multiply by 4. Divide by 3, multiply by 4, so 4/3 du is equal to 4x squared dx. So this whole 4x to the 5th thing, I'll write it as 4x squared times x cubed. So I now have 4/3 integral du. What do I cross off? 4x squared and dx, those are gone. What do I replace this with? U cubed. And then what do I replace the x cubed with? Yeah, u plus 4. Is u plus 4? No, u plus 4. 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 You call me a nerd. Of course I'm a nerd. I have a degree in mathematics. Dr. TJ, he's in the hallway. I'm trying to wave him on over here. He's not coming on in. Here, he's coming in. When he comes in, everybody clap for him, okay? Wait. Yeah, make sure you stand up for him. Look at that. Dr. TJ, we were encountering some difficult calculus, and somebody said, I need to pick me up, Mr. Gibbs. I just saw you walking down the hallway, and I knew that would help get us through. Wouldn't you guys agree? Not. See, yeah, will somebody want to explain to him how it works? And then what do we do with it? Post it on YouTube because oh my gosh, like 314, I think. Good times. Yeah, thank you. Appreciate that. All right, so we got 4/3 integral u to the 4th plus 4u cubed du. Antiderivative of u to the 4th. U to the 5th over 5 plus antiderivative 4u cubed. Just u to the 4th. Does that kind of make you happy when it just works out like that? It's like, oh yeah, that was very nice. Plus some constant. All right, it's kind of easy right now, right? We just throw u back in there, which is x cubed minus 4. So we got 4 times x cubed minus 4 to the 5th over 15 plus 4 times x cubed minus 4 to the 4th over 3 plus a constant. That's beautiful right there. Oh yeah, no, I knew, that's how I figured it out. So, all right, we got two more. This was a little bit easier. Next was a little bit more difficult. Cosecant to the 4th and cotangent. I got to decide what u is in this situation, and this is kind of just a little bit of a trick. Help you kind of think for a little bit further than normal. Suppose we have u is equal to cotangent of x dx. Well, yep. Suppose we have u is equal to cotangent of x. Anybody remember what the derivative of cotangent is? Of course you do. Yep, negative cosecant squared. Good job, Ishka. So that's, sorry, got a dx over here. My professor would have taken points off for that. Okay, Professor Connor, are you happy now? There we go. All right. So suppose we had, instead of u, suppose we had u is equal to cosecant of x. So suppose we switch it instead of u being cotangent, because I see cosecant squared, we got cosecant to the 4th, but suppose u is cosecant, then du would be what? What's the derivative of cosecant? I need somebody to say it loud enough so that they own it and are proud of it. Excellent. Negative cosecant of x cotangent of x. Negative cosecant of x cotangent of x. So that's kind of tough. Do you think we choose the top or the bottom? Okay, you just pause there, and I'll see if you can make up your mind now. What if I rewrite it like this? Cosecant cubed of x times cosecant of x cotangent of x dx. Do you agree that those two are the same? Now, what would you choose u to be, the top or bottom? Yeah, it's definitely the bottom. So in this situation, u is equal to cosecant of x, because when you take the derivative of cosecant, you're going to come up with that guy right there. See how nice that is? So u is cosecant. Very good. We'll get rid of that. Du is equal to negative cosecant of x cotangent of x dx. Multiply by that negative. Negative du is equal to cosecant of x cotangent of x dx. Who can tell me what my new integral looks like? Negative integral. Okay, du, fine, I'll throw that there. U cubed, excellent. So if you get confused, just start crossing stuff off. You got the negative du, and that's going to get rid of cosecant cotangent dx, so I get rid of that. So you got this left over, which is u to the 3rd. So I've got u to the 3rd. Antiderivative of u to the 3rd? Yeah. Negative cosecant to the 4th of x over 4 plus a constant. And there it is. Not too bad, huh? Last one. Scared? What is u, Riker? U is equal to 3 minus x. What is du? Negative dx. I don't have a negative dx. I've got a 3x squared dx. Oh, we get rid of the negative, we add the 3 in there. So multiply by negative 3 du is equal to 3 dx. You can't add, but you can multiply. Don't want to multiply the x squared because then this side would have an x squared, right? And there's nowhere here that says x squared du, so you can't make that substitution. Okay, this is tricky. What are we not accounting for? The x squared. Somebody. So if I get u is equal to 3 minus x, I can add the x over, and I can subtract the u, correct? So everybody okay with x equals 3 minus u squared? X squared is equal to 9 minus 6u plus u squared. I have all the parts necessary for my substitution. I'm going to start with my negative 3 du. Negative 3 integral du. What do I get rid of? Yeah, I get to get rid of that and that. Now I'll get rid of my x squared. What do I put in place of x squared? 9 minus 6u plus u squared over u to the 1/4. Oh yeah, that's kind of ugly, but it's going to be really cool. I'm going to write this as negative 3 integral. I'm going to have to divide each of these top terms by u to the 1/4, aren't I? So it's going to be 9u to what power? Negative 1/4. Minus 6u to what power? 3/4. Plus u to the 7/4. You want to multiply through that negative 3 through right now? Or do you want to do it at the end? Right now? Okay, we're going to go with Josie. It's her birthday. Integral of negative 27 u to the negative 1/4 plus 18 u to the 3/4 minus 3 u to the 7/4 du. Piece of cake. Upside down. What is the antiderivative of negative 27u to the negative 1/4? Negative 27u to what power? 3/4 divided by 3/4 or multiplied by 4/3. So times 4 over 3. Plus 18u to the 7/4 divided by 7/4 or multiplied by 4/7 minus 3u to the 11/4 divided by 11/4 or multiplied by 4/11 plus a constant One step left. We plug in u and we simplify our fractions. U is, what was u again? 3 minus x? Okay, so the 27 over 3, that divides to 9, negative 9, and then multiplied by 4 is negative 36. 3 minus x to the 3/4. 18 times 4. 72. 72 times 3 minus x to the 7/4. All over 7. Minus 12 times 3 minus x to the 11/4 over 11. Plus a constant. If you take the derivative of that, you get that. I mean, come on, boys. That's like, you take the derivative of that, you get that. Remember how we started out this unit? We took the derivative of something, and it should match up what we were taking the integral of? I dare you. Go home. Try it. Take the derivative of that, see if you can come up with that. Do it. Like, I think it might be doing it. Like, if you guys come around after school and you come get some help, like if there's like some free time there, I think I might just try that. Because I don't think I've actually done that one before. That looks kind of fun. Oh, what if this is not an extra credit problem? What if this is a problem on your test? Maybe I'll write like 6 problems for a test and that'll be it.